Okay, now we're talking about Newton's first law. Newton's first law is kind of a Captain Obvious law for part of it, but the other part is really a little bit of a head scratcher. In words, Newton's first law says an object at rest will remain at rest. Duh, we know that. But where Newton goes a step farther is an object in motion with constant velocity will remain in motion with constant velocity unless acted upon by a net force. You can also say unbalanced force. There just has to be something left over to cause an object to change its speed and or direction. It's also known as the law of inertia. More about that in just a minute. Okay, a force is a push or a pull. The metric unit of force is called the Newton. A Newton is probably a new unit for most of us. And also probably the single most important thing to remember is forces are vectors. Their length matters and their direction matters. Now 1 Newton, now that's all screwed up because it didn't transfer over right. 1 Newton is equal to a kilogram times meters divided by seconds squared. Understand that in this class we're going to focus on meters, kilograms, and seconds. Those are going to be our 3 base units. We're not going to go all the way back to grams. We deal with big things, so we're going to go to kilograms. A Newton is a kilogram times meters divided by seconds squared. You probably want to write that in your notes better than it showed up when some reason it didn't transfer over right. Now, to give you an idea of what a Newton is about the weight of a medium-sized apple. So for a reference point, I would weigh probably in the neighborhood of 1,000 newtons. Most of y'all are less than that. Now, a net force. A net force is simply the vector sum of all the forces acting on an object. If the forces are balanced, there's no net force, and the object would be in equilibrium. If there is an unbalanced force, then you have a net force. Unbalanced force and net force, those two words can be used interchangeably. They both mean the same thing. Well, that leads us to the question of what do unbalanced forces do? Unbalanced forces are what cause the second part of Newton's first law to make sense. An object will continue in its current state of motion unless an unbalanced force acts upon it. So if an unbalanced force acts upon it, it's going to change its motion. It can speed up, it can slow down, it can change direction. Those are the 3 things that an unbalanced force can do. I guess it could also change shape of something. The first part of the law really is again, Captain Obvious. Objects at rest stay at rest. Those bowling balls are not going to start moving unless they're forced to move. Now, they could be forced by gravity, they could be forced by your hand, but something has to make them move. If nothing makes them move, they just sit there. They sit there because they have inertia. Now, objects that are moving at a constant velocity, that means straight line, constant speed. Straight line, constant speed is constant velocity. And unless they're acted upon by a net force, this is again not as easy to see, and again was misconstrued by the ancients for thousands of years until Galileo and then Newton picked up on it and kind of put people in their place and said that objects have to be forced to change motion. Prior to that, they thought objects they only needed to be forced to speed up, but they didn't need to be forced to keep going. We need to have things to be forced to make them speed up, slow down, or change direction. Now, the reason it was not easy to see is we don't see very many frictionless environments on Earth. Air hockey's kind of close. Things in orbit moving through space are also kind of close. And remember, those were foreign things 2,000 years ago. I doubt Galileo could even deal with the concept of an air hockey table. Static equilibrium. Static means stationary. Equilibrium means equal. So the net force on an object is 0. That means the sum of all the forces equals 0. Rest or constant velocity in a straight line. Remember, it takes an unbalanced force to change the speed and or direction of a motion. And we'll talk more about that with Newton's second law, but it's important to understand what the word equilibrium means. Equilibrium is a fancy word for equal. Now, inertia. This is a word that sometimes can confuse people a little bit. When it gets down to it, though, it's not really that complicated. Inertia is the tendency of an object to resist a change in motion. In other words, inertia is how much something wants to stay moving the way it is. So if you have something like a school bus has a lot of inertia. It's not easy to start moving, but it's also not easy to stop moving. Now, inertial mass is how hard it is to change an object's velocity. It is measured in kilograms. So in other words, when we change velocity, we have to change velocity with a net force. We want to figure out what it takes to change the velocity, and that will lead us to the concept of inertial mass. Mass is really a measure of inertia. I have more inertia, therefore I have more mass. Now look at this question. Which object has the greatest inertia? Which one has the greatest inertia? Well, we can instantly cross off some that don't make sense, and I already crossed one off that doesn't make any sense. Obviously, the helium balloon doesn't make any sense. Like that. Doesn't have much inertia. A falling leaf, not much inertia. It's not hard to change the speed of a falling leaf. A softball in the air, kind of hard to change, but not nearly as hard as a seated student. Students are hard to move. The bigger they are, the harder they are. Remember, inertia is simply a measure of mass. So which object has the greatest inertia? Well, I have 4 different masses, and I have 3 different speeds. Well, inertia equals mass. Greatest mass is a winner. Doesn't matter if it's standing still. Inertia is mass. That's all it is. Remember, Newton's first law, objects at rest stay at rest, objects at constant speed stay at constant speed unless acted upon by a net force or unbalanced force.